Our next section for geometry would be measuring segments. And the objective today is to find and compare lengths of segments. Before we can get into that, we have to know different terms. So when we're talking about a coordinate, it's a real number that corresponds to a point. You typically have seen coordinates on a number line. All the numbers on a number line would be coordinates. And the distance between two coordinates would be using this formula. If you don't remember, these lines right here mean absolute value. You have to do any math inside the absolute value lines before you can take the absolute value, which is meaning that it's a positive number. When you're walking down the street, you would never say, I'm walking -5 feet, because of the fact that distance is not labeled with negative numbers. So that's why we have those absolute value signs. So when we're looking at a number line like this, and we're saying, what is the measurement of CD? So first I have to be able to read this number line. If I look here, each dash mark I can see is 2. Because this is a dash mark, and then another dash mark is 4, so in between those it would have to be 2. So we're counting by 2's here. So CD is this line. So I have 2 and I have 10. So using the formula that was on the slide beforehand, this is my first number, so I have 2 minus 10. So again, you first take what's inside the absolute value, which 2 minus 10, that's going to give me a negative number because subtraction right here is going to be negative. So I have the absolute value of -6, which would be able, once you take the absolute value of that, would be 6. So that is my answer. So another postulate that we have, so you want to make sure to write this down, is the segment addition postulate. And some people might see this and think, well, duh, this section plus this section will give me the whole section. That's basically all this is saying. If you have one full line like we do here between AC, and it's broken up to 2 smaller parts, those 2 smaller parts will make the larger part. So make sure you write. So if we're going to use a segment addition postulate, it's telling me that LN is 32. So before I even go on to the problem, I'm going to label LN, this segment right here, is 32. And it's asking me, what is LM? So what's this length? And what's this length? And MN. So by the segment addition postulate, this is saying we can take our 2 smaller lengths, the 2x plus 4, plus we can add 3x plus 8, and that can be equal to 32, because that's my whole. Now when you're solving this, you want to first find any like terms. Well, this has a 2 and an x with it. Here's a 2 or a 3 and an x, so those both have variables x. Here's just a number and here's just a number. So now if I put those together, I would have 5x plus 12 is equal to 32. So when we are solving this, we first want to get rid of this plus 12. So I have to think, what's the opposite of adding? Well, if I want to move that, that's subtract 12. Whatever I do to one side, I have to do to the other side. So I have to subtract 12 on both sides. That's going to leave me with 5x on the left-hand side, because this will cancel out. And 32 minus 12 will give me 20. And now I'm looking at this, and I have 5 times. Whenever there's a number right next to a variable, that means multiply. So 5 times x, to get rid of multiplying, I have to divide. So divide by 5 on one side means I have to divide by 5 on the other side. And I get that x is going to be equal to 4. But that's not my final answer, because my question actually is, what are my 2 lengths? So what I have to do is go back to my original problem, and plug in, now that I know that x is 4, I can plug that into my 2 equations. So for this first equation, I have 3 times 4 plus 8. So that's going to give me 12 plus 8. This is going to give me 20. And to figure out the second one, you can do this one of 2 ways. You could plug in x is 4 again, the 2 times 4 plus 4. and get 8 plus 4 is 12. Or you could have subtracted from the original that we saw. I could have done 32 minus 20 and still get 12. So that's how I'm going to use the segment addition property. I know that this is kind of hard to see, but this portion right here goes to EF, and this portion right here goes to FG. Right now, I want you to try to solve for what EF and FG would be equal to. Make sure to push pause because I'm going to show all of my work. So hopefully push pause, and I have showed you all my work here. So what I first did is I took both of these two different equations and put them equal, added them together and put them equal to 59, because that was my total, EG. I combined in like terms. 8x plus 4x gave me 12x. This subtraction has to stay with that 14, so that's kind of like a negative number. So when I combined my negative 14 and positive 1, I got negative 13. So then I have to solve for x. First I added 13 because I had to do the opposite of subtract, and then I divided by 12 because I had to do the opposite of multiplying. And I got x is equal to 6. And as you can see, I plugged in 6 into both of my two equations. If you want to check your work then, so I got that EF is equal to 34 and FG was equal to 25. If I add those two together, I get 59, which is the total. So it all checks out. Our next new term here would be congruent segments. So again, when we're talking about in geometry, when we're talking about a segment, it's going to be like a line that has two endpoints, like so. Now let's say if I label this AB and this CD. When you're talking about congruent segments, one way that we show in a diagram that two lines or segments are congruent is by putting the same dash mark to represent that they're congruent. Now if I would have put two dashes on AB and one dash on CD, that shows me that they're not congruent. So you have to make sure that they have the exact same symbol representing that line. So that's how you would show it on a diagram. If you were to write it out, it would look like this. AB, and again, when you're labeling that, it's just a straight line with no arrows. An equal sign with a little squiggle, that means congruent. And that's congruent to CD. So that's how we represent when we have two line segments congruent. So if we're looking at this and it says, are AD and BE congruent? There's two ways to solve this. Just like we went from the first slide that we went to, I can look at AD right here. And again, we're counted by twos. So B is at negative 2, here's negative 4. This would be negative 6. And D would be, here would be 2, 4, 6, 8, 12. 10. Sorry. So if I did like the original one from the first slide, I would have the first letter is negative 6 minus 10, and the absolute value of that. Again, the absolute value are these two lines. So first I have to do negative 6 minus 10, which actually would give me negative 16. And if I take the absolute value of negative 16, I get just positive 16. So you could do it that way. The other way you could do it, if you wanted to, you could just count it. I'm okay with that. So I know that each section in between this, the little dashes is 2. So if I start at B and I go to E, I want to see if that's going to be equal to 16. So if I look, here's 2, 4, 6, 8, 10, 12, 14, 16. So I just counted, yes, that's equal to 16. So my answer would be yes, they are congruent. Woohoo! So another key terms that we have here, make sure you pause and you write these down. Midpoint is if I have a segment, the midpoint would be right dab in the middle, mid. And if this point is in the middle, that's putting it right so that these two smaller segments would be congruent. When we're talking about bisecting, so midpoint is just a point, but bisect means that if I had, again, a similar type of picture, and if I were to draw a line, this line goes through that line AB, that bisects it. Let's say that this is line L. Line L bisects, meaning that this line cuts again these two into two congruent parts, because at this point where that line goes through AB, it's creating two congruent parts. So segment bisector, it's kind of like the same thing, but if I were to have again a line AB, but instead of drawing a line, I drew a line segment, then that's the same thing. It's a segment bisector, and this is also just a segment right there. If I look at this picture right here, it says S is the midpoint. So before I read on or look at the picture any further, since S is right here in the middle, midpoint, I'm going to already label that this RS is congruent to ST, because that is what midpoint means. Now I have to find what each is equal to. Well, if I know that these two segments are congruent, that's the same thing as equal. So I'm just going to put an equal sign right there. Once you have an equation, you can always solve for any missing variables. So what I like to do is I like to move all the variables, or the x's in this case, over to one side. So right here, this is a positive 3x. To get rid of a positive, I have to subtract. So I'm going to subtract 3x from both sides. I have 4x minus 3 is equal to 1. Now this says subtraction, so the opposite of subtracting would be to add. And I have 4x is equal to 4, and this is 4 times x. So opposite of multiplying would be dividing. And now I have x is equal to 1. So now I can solve this. And here's the nice thing about having a midpoint. I can pick either one of these two equations here, because definition of midpoint means that these two are going to be congruent to each other. So it doesn't matter which one I put it into. So I'm going to pick 3 times 1 plus 1. That's going to give me 3 plus 1 would give me 4. So RS is going to be equal to 4. And then I know that ST is also going to be equal to 4, because those two are congruent. And then when I'm looking for RT, you could do two things. You can either just add up the two numbers you already have, or else you could put it into the original equation, kind of like we do the segment addition postulate. But that's a lot more work. So here are my 3 answers. So that is it for today. Make sure you fill out the Google form and submit your problems. Have a wonderful evening.